All right, afternoon, evening, everybody. We are going to be starting today's lecture. It is on OOP, which is object-oriented programming. This is where your functions, functions, your methods are going to be moving from functional programming to what is considered class-based programming. This gives you a little bit more. It's a way to organize code. There's a lot of different ways you would solve a problem. Object-oriented programming is a kind of a different methodology on kind of solving problems. As you kind of step into it, you can see a few of the normal uses where you'd say, oh yeah, that's obvious. I would use OOP for this, I wouldn't for that. But the more you lean into it, the more you can start to, it's almost like a different language. You'll start seeing different solutions to the same problems, or you'll start attacking things in a different way. And I wouldn't say you ever fully have to commit to OOP if you don't want to, but it's not something I would specifically try to not learn, because at some point you're gonna need to read it. But you can get away with never really using it, but not in this class. You can't. So I'm going to teach you how to do it. It's a little different than what you're used to, kind of going on, at first. And feel free to stop me at any point if some of this doesn't make sense. But I want you to kind of think about what you know about objects in JavaScript and dictionaries in Python. And this is going to kind of look like that, but rather than it being a data type, it's going to be a full-blown instance of a class that you've instantiated. It'll make more sense as we go. Kind of some stuff I've talked about. So if you didn't know, Python is an object-oriented programming language. Everything's an object. That's maybe useful to know. Maybe it's not. You can. It's something you can kind of pull out of your hat and tell people, but doesn't necessarily affect the way you use it a lot in relation to other languages. But it's something to think about. Objects or data structures. They have methods and attributes. You can think of them as nouns. They do have adjectives, verbs. I don't know if I really love this description, but I do like dogs. So we're going to kind of look at how this interacts with dogs. Oh, this is a really cool piece here. So I didn't know this, and maybe you guys do know this. If you're not sure of all of the possible things you could do, or by things, I mean, I guess built-in methods for, objects in Python, you can wrap it in this help call here, and it'll just kind of tell you all these different things you can do. Oh, we should use a code for this. So, for instance, if I were going to, spinning. Oh my goodness. Hold on, let me. Oh no. My Vim extension is working, and I thought I turned it off. Okay. All right, there we go. Sorry about that. So if you did want to, build something like dog, and you got breed, and then let's say we're used to it, your chow, lab chow, you can wrap this in help and print that out. And see some pretty interesting stuff. Is that too small? That might be too small for you all. So it'll print all this information out that kind of shows you, what this is, things you can do with it, kind of built-in, functions, how it works, just kind of everything you can do with it. These more important. Pop item, set default, update values. These are all like functions you can, or methods you can run on a dictionary. And so that's pretty handy. That's nice documented bit of information there. But we'll continue. I just thought that was super cool. I've never seen that. We're also going to see things where these are called Dunder. I guess they call them Dunder methods or magic methods, things like that. Basically, it's when you see 2 underscores, a word, and then 2 more underscores. Under the hood, Python's doing that every time for everything. Most of these methods have these kind of Dunder methods for them. You can learn a lot about them from this link. I would encourage you to check it out if you're interested. I'm not going to dig too deep into that because it's a pretty big rabbit hole, but some pretty simple things like just the plus sign when you're adding 2 things together. There is a Dunder method for that is actually being ran behind the scenes. It doesn't, the plus sign is being replaced by that when it runs. But to get into classes, I'm going to drag this out of the way so we can just kind of work here. So if you're following along with me, I can't pull both these things up on the screen at once. This is how you create a class. You use the word class. Handing it this pass just so nothing happens, and then we're going to run this. But I've instantiated a class called dog. And then just like any other function, you have to invoke it. But you can set the output of whatever that is to a variable here. So just like any other function, if I wanted, I could set a variable attached to a function. When that function is ran, the output of that function is going to be set to that variable. So that's kind of what we're doing here. I'm not going to, we can run it. Nothing's going to happen. As we expected. But now we're going to add a little bit more to it. So what we're doing here, with this class called dog, we can set class variables that pretty much every time you run dog, when you invoke dog, this class, these are going to be included with that. The instance is going to include those, all of them, no matter what, when you output it. And the way you refer to that is with this self bit here, which looks kind of annoying to use all the time, and it is. But that's how Python does it. There are languages that get around this that are smart enough to infer what you're doing, like Ruby, but at the same time, it'll make a little bit of sense as we kind of talk through it. But you do want to specify that this is, hey, this is my variable and not, the variable that it, from some other function is using. This is the one that belongs to me, the instance of dog here. So what we've done here is we built a class called dog. We've set 2 variables, eyes and legs. So we decided every dog ever has 2 eyes, 4 legs. I said 2 earlier, 4 legs, 2 eyes. There are no other dogs that exist, beyond this. Every single dog from now to the old time, this is what they have. We've also built a function within this. So there is a class of dog, but we have class functions within it that now let us run these functions that are associated with the class. So the difference between class and functional is we would probably just, if we were doing functional programming, just have a function that takes in dog and attaches, and attaches variables to it, or just runs its variables. But when we're doing class-based programming or object-oriented programming, we're going to set those variables here, and then we're going to also give dog these functions that it always has with it. It's going to carry with it no matter what. So seeing in action here, we've set a variable called dog. It is the output of whatever running this is, these parentheses here saying we're invoking the dog class. So dog now exists and has access to everything in here. So dog.display_info is going to call this function within dog. So it should print out this information as it does. So because we're calling this function that's built in here, it's going to run, this function here. If we were just to run it, without that, it wouldn't do anything because we're not calling this function anymore. We're just instantiating, an object called dog. It's not doing any work at all. But we do have access to these variables, I believe. So we could do something like dog.eyes, or does that work? I don't know if this works actually. We're gonna see how good Jordan is at Python. Okay, yeah, so we're not going to be able to call it that way. But basically, this class does have variables that we could access. We'll get there. That's what I get for going off script. Does that make sense to everyone? Did this throw anyone off extremely much? I didn't mention you do have to. You just have to do it. You have to put self in here and any functions you create within the class if you want them to have access to these variables.
So I have a question.
Yes.
When you create a variable dog and assign it to that dog function with capital D, does that transform the class into a function, or just gives access to the class dog? I don't understand why function.
That creates, so all this is doing is saying, hey, this is a class of dog. If you want to use me, this is all the information you're going to get. Running it here says, hey, I'm going to create a new variable called dog, and it's going to have all of the stuff built into here. If I wanted to build a second one, I could say dog2, and ran it like that. That is a whole new instance. These don't talk to each other. I can make changes to this dog that won't necessarily affect this one. And we'll see that here just a little bit. Actually, I think that's the very next thing. So yeah, it's pretty much what I just showed you. So we've got John's dog and then Josh's dog. Y'all know John, y'all don't know Josh, but they were both instructors at one time. Seeing this in action, you're not really going to see anything different right now because we didn't make any specifications here, or we didn't change anything. These are both going to be the same output, but they're not really the same object, so they will behave differently. Okay, so I'll just copy paste. To expand on this, these right here, so as we talked about, these are the class variables. These exist no matter what. You can't have a dog without these. We've decided all dogs have these. These are what do you call these? I think instance variables is what they're called. So when you instantiate dog now, with the way we've got this written, when you init it, it's going to require you to give it these things now. So anything in this Dunder init function are now required to call dog. We can't just say, hey, dog is equal to, capitalized dog parentheses. It now is going to be expecting these, I guess you'd call them positional arguments. These are required to instantiate dog. So we have said, to create this function, you're now going to have to provide me with a name, a breed, and a color. So that makes sense, right? Because we're assuming all our dogs have 2 eyes, 4 legs, but not all dogs are going to have the same name, color, and breed. We still have our display info, but now when we invoke this, we're going to have to feed it this information. So this John's dog It's got a name, Lucky, golden retriever, color gold. Joss's is Lassie, border collie, black and white. When we go to run these, you'll see they have different outputs. They still have the same 2 legs or 2 eyes, 4 legs, but you're seeing the differences in the name, breed, and color because they were instantiated with different values. So we're starting to see, oh, what's up, Guillermo? So I guess as what I explained earlier, saying they're 2 different objects. Now you're actually seeing that in action. There are 2 different objects that act independently of each other. Does that make sense to everyone?
So just so I have this clear, anytime you define a class and then you do that init, that will prompt you for some attributes if you try to turn that class into a function, correct? Is that what that's doing?
I don't like the part where you were talking about turning a class into a function, because that is not what we're doing. We're instantiating it. We're creating an instance of the object. And it's not necessarily going to prompt you. It will blow up on you though. And I'm pretty sure we can see that in action. So if I try to create John's dog, but I don't give it a name, and I try to run this again. Oh, hey, look at that. Missing 1 required positional argument name. So just like normal functions, if it's expecting a positional argument and you don't give it to it, it's going to blow up and say, hey, I can't, you didn't give me the stuff I need. So anything in the init class is saying you absolutely have to give me these before you're allowed to create a function, or sorry, to create an instance of this object. Okay.
Is that a constructor? What you've got up top there? Is that what that is? Basically the int, the self-named breed. Is that basic constructor function?
I don't, well, that's not a Python term, I think, for this. We're going to call that, I guess, instance variables in this case, and they're required to be instantiated when you start this. Constructors, I don't want to talk too much about that out because I'm only familiar with using constructors in JavaScript, and that's kind of a different thing. But I'll look into that or look more into that with you afterwards to make sure I'm not leading you astray or lying.
Okay, no problem. It just looked familiar. That's what I thought it was, but maybe not.
Gotcha. Okay. So now what does this talk about? So class variables are what I wouldn't, you could associate them with like constants. You have you've got variable, or in JavaScript, you've got your let, to create a variable that you want to change, you've got let, but you've also got constants that you don't want to change. Anything that should change or should not change, everything that should exist, throughout all of them, that's what class variables are for. You don't want to have class variables that shouldn't be associated with every instance of this object. This example here kind of shows a good reason, or sorry, a good purpose for them. If we were to build a class called employee, number of employees, we do kind of want to, we'll start at 0, and then this will kind of ramp up as we create more employees. So this class will kind of save that information. As we're creating more employees, you'll see that number kind of iterate. And then we're using this kind of like a constant here. But nothing crazy here. First, last name, pay. We've got an email here, and then employee dot number of employees plus equal to 1. So basically, when this class is instantiated, it's going to run, it's going to add 1 to the number of employees here, because this is just kind of built into the instance. So when it's instantiated, everything within the underscore init is something that's going to affect the entire class, and it's going to be ran each time. You have to, it runs everything in this block. But then we still do have this apply raise that we can call independently. So if we run these, let's see. Oh, that's not printing anything. It's always supposed to be wrapped in, isn't it? Cool. So we create one employee. We can see that the employee number has gone up to 1. We create another employee, it goes to 2, just as we expect. Any questions on that? It feels straightforward to me. But I understand if that is weird. All right, we're gonna go back to dogs. This is an example of why, how you have to kind of be careful with your class variables. Oopsies. So something that I guess you could fall into a trap of doing something like this. All dogs should have tricks, right? You want all your dogs to have a list of tricks that they learn. And you would think that maybe, that belongs up here because yeah, all dogs are going to have tricks, right? But you don't really want to put it here. The reason for that is, it's a lot of extra stuff. So we're instantiating a dog here. This one is going to be named Fido. This one's going to be named Buddy. For Fido, we have added a trick, roll over. Let's see, and we'll prove that that works. And for this one, E, which is Buddy, I don't like these names. We're adding another trick. And what you would expect is the output to show the first dog only has rollover, the second dog has play dead. But that's not what's going on, because we're adding a trick here to tricks. So, the first dog does have that. But then when we go to add another trick, it's not adding it to this dog. It's adding it to the class variable tricks. So every dog ever is going to be learning the tricks, which is, not what we want to do. The proper way to do that would be to put it in the instance. So the instance of that dog learns the trick, and not every other dog, does. So I like that so much. What did I do there? Oh, okay. So does that make sense to everyone? Why we're not? I guess why these tricks are all being associated with one dog and not all dogs, and that's different than what we did before.
I got a quick question.
Yes.
So you don't need to put, when you on like line 11 where you got D equals dog and then the dog's name, you don't need to put name equals Fido, name equals Buddy on line 12. You don't need to do that, because I noticed on the John and Josh's dog, you did it on the first but not the second. So is that just to kind of let us know what's going on?
Correct. Yeah, so if you don't specify what instance variable you are, associating this with, it's going to take them in a positional order.
Yeah, so I figured.
So just like you should be familiar with functions at this point, it's going to, take them in that order if you don't want to infer, which is the kind of the normal way to do that, but it's nice to have options on that. If you've got, quite a bit of information you're throwing in there, and when you're seeing it instantiated, you kind of want to know what's getting plugged in rather than have to look at the class and look at what you're doing. But yeah, that's two different ways to go about it. That is it for this. I'm going to stop recording, and I will actually, if anyone's got any more questions, probably a good time to ask it while I'm recording. Otherwise, I'll kill it.
So the D and E that you have there, and those are objects now, because they're taking the instances, like you use D dot, and you can do add trick, or you can do name, I guess. You take, so those are objects, right? D and E.
Yes, I would consider that they are objects at this point. I like the word instance
Okay,
in this
but they behave like
instance.
objects.
Say again.
They behave like objects.
They do behave like objects. Everything behaves like objects in Python.
Okay, okay. Because they'll, yeah, okay. I see. I think I understand it better if I think of them as objects.
Okay, cool.
Okay.
All right. If that's it, I'm gonna stop sharing and we'll keep moving.
Jordan, just have a
right here.
question. Oh, sorry. Yeah.
Can you say that again louder?
Go ahead.
So for line 4, don't we? So we don't. It's not needed to put tricks there.
I can barely hear you. I'm so
Sorry. Can you hear me? So in line 4, so it just says in the parameter, there's just self and name. So you don't need to put all the attributes in that one. In line 4.
You do. So this expects. So what this is doing here? So self is, it has to be plugged in. It's just the way it is, especially when you're any function that exists within this class that you want to have the ability to refer to its own class variables. Is going to need the word self in here. So this goes in. It's boilerplate. Just do it. You can't. It won't work if you don't. And then we have to give it a name here, because on line 5, we're saying, hey, this is an instance variable of dog, so self, called name. And we're going to set it to whatever is passed to me here. We don't do that with tricks, because tricks is just creating an open, an empty list. So that's why tricks is not necessary here, but name is.
So if we did like a on the def in it, we have self name. Could we do like a comma tricks and then self dot tricks we equal tricks? And then that way you could just pass tricks with the name down there on line 11.
Yeah, you absolutely could.
Okay. Yeah, I'm just trying to understand, because this is a foreign concept for me right now.
Yeah, yeah, you totally can do that. If you wanted to build it and say, hey, my dog has to have a trick. Every dog's got to have a trick. There are no dogs that don't have tricks. That would be, I guess, the logic to doing it that way, or however you want to do it. But that is true. That's how that would work.
Okay, so the first function there, the init, it automatically defaults to name whenever you're calling the function. Okay.
Yes.
I see what you're saying. And so the second one, you're pretty much just calling the function with the object name there. Okay, yeah.
Okay.
Would putting tricks up on line 4, would that limit you to just putting one trick? So like just sit instead of having like sit, lay, roll over, or whatever, if you had the self.tricks equals the empty list?
I'm not sure I understand the question.
I just didn't know if you could put multiple tricks when you define like D equals dog Fido, if you could put like multiple names, or if that would just pinhole you to one trick. And that's why you did it like that.
Yeah, so that's probably, that's a good point. Because you'd never be able to add more tricks to the dog without reinstantiating the dog. If you created a new dog with the same exact name, I think it just overwrites it. Let's test that. So I got it. First dog, and then a second dog. And let's see what it does for us. Or sorry, that's not right. I missed. Yeah, so it doesn't overwrite it. That's totally allowed, but you're going to have dogs with the same names. But yeah. So that is a good point. And we can let's see here. I just want to display this really fast. That's right. So I already changed it. Cool, there. So it added the rollover 3 times because I added a trick 3 times. So we have we've proved that that works. And as many times you would run that, you can keep adjusting this object as long these objects exist basically as long as this file exists and as long as the Python shell is running this. And they will disappear when Python stops running, basically. So you can do as much as much with them as you want. You can continue to make changes to them, continue to utilize them, continue to call them. It just exists now as an instance. But
So could you print the entire function and just get name and tricks all in one line or in one go? So instead of just saying print d.tricks or print d.name, could you do print a function maybe?
are you saying like that?
I guess, yeah. I was just trying to see if you can get the name and tricks all in one go.
Oh, absolutely. Yeah, I mean, we could there's a few different ways we could go about that. We could say d.tricks and then wrap this one up and get d.name. Or what probably is the better way to do that, if you did want to constantly recall this information, you would make a function that does the same thing.
Okay.
So you can do something like def dog info. Doesn't really need to take anything, and I would just probably print or return this, however you want to do it, and that ought to work. We should be able to do d.dog info and invoke that. I think maybe you don't have to invoke it here. Okay, so yeah, you do. I think the way you would want to do that then is to return.
Well, I think you got it on that line unless you already did it before.
That was, oh, maybe I did do it. Did I get it right?
I thought you did.
He's not, oh shoot, I already. Cool, yeah, it does it. So you could call it out like this, when you want to get the info, or you can make a function to do that. You can keep adding functions to this class to do all kinds of different things with dog as you go. It's just it's just a different way to kind of look at solutions. Building out the structure. Structure is a different word for it in different languages, but it does a good idea of explaining kind of what it is. It's this big object of an instance that you can kind of plug things into and do stuff with it. It works really good for nouns, like people make really good objects for object-oriented programming, but you can do much more with that. You can do more, like less concrete things, more abstract things, like building some solution that is a function that does all kinds of different, different stuff. All kind of, you do math with it if you wanted to, if you want to be boring like that. But anyhow, all right, I'm gonna stop sharing. I think we've got a lot of good questions done, and I'll obviously still be here to answer them. I'm gonna pause this.